Good morning, HOD sir, DK Chaturthi sir, my seminar guide Dr. Vikas Bansal sir, seminar coordinator DP Sharma sir, faculty member, examiners and my batchmates. I am Hemant Menariya, pursuing my BTech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today I am blessed to be here in front of you all to deliver the presentation of my seminar topic, Advanced Engine Cooling System. This is an overview what I will be presenting you in this topic. These are the topic which we will discuss in this topic. Let's start with introduction about engine cooling. So, what is engine cooling system? Cooling of engine with the help of air and liquid is called engine cooling. Engine cooling system remove waste heat from the internal combustion engine. The cooling system is composed of 6 main parts: an engine, a radiator, a water pump, a cooling fan, hoses, and a thermostat. Now, there are two types of engine cooling system. First one is air-cooled engine cooling system, and second type is water or liquid cooling system. Here you can see in this diagram, this first one is air-cooled engine cooling system, and this second one is water-cooled engine cooling system. First diagram, you can see this fins plays an important role in cooling, whereas in this water cooling system, a radiator, a compressor and pump plays an important role. This is a brief intro about these two types. In upcoming slide, we will learn more about these two types of engine cooling systems. Now let's talk about conventional engine cooling system, which we were using from decades without any major modifications. So when the combustion of air and fuel takes place inside an engine cylinder, hot gases are generated inside engine cylinder. These hot gases can rise engine temperature up to 2300 to 2500 degrees Celsius. So it becomes very necessary for us to reduce this temperature to a certain level so that our engine can work efficiently and without any major damage to our engine parts. Now let's understand what is the basic principle of engine cooling. Cooling system works by constantly passing coolant through channel in the engine block. Coolant driven by a water pump is pushed through the cylinder block. As the solution passes through these channels, it absorbs heat from the engine. This heated fluid enters the radiator, where it is cooled by the airflow entering through the car's radiator grill. The fluid will cool as it passes through the radiator, returning to the engine again to pick up more engine heat and carry it away. There is a thermostat between the radiator and engine. Depending on the temperature, the thermostat regulates what happens to the liquid. If the liquid fluid temperature drops below a certain level, the solution bypasses the radiator and is instead directed back to the engine block. The coolant will continue to circulate until it reaches a certain temperature and opens the valve on the thermostat, allowing it to pass through the radiator again for cooling. After the liquid in the storage tank has cooled to an acceptable temperature, it is returned to the cooling system for recirculation. Here you can see it is a diagram of engine cooling system. Now let's talk about working air cooling and water cooling system. A cooling system works by sending a liquid coolant through passages in the engine block and heats. As the coolant flows through these passages, it picks up heat from the engine. The heated fluid then makes its way through a rubber hose to the radiator in the front of the car. As it flows through the thin tubes in the radiator, the hot liquid is cooled by the air stream entering the engine compartment from the grill in front of the car. Once the fluid is cooled, it returns to the engine to absorb more heat. The water pump has the job of keeping the fluid moving through this system of numbing and hidden passages placed between the engine and the radiator to make sure that the coolant stays above a certain temperature. If the coolant temperature falls below this temperature, the thermostat blocks the coolant flow to the radiator, forcing the fluid instead through a bypass directly back to the engine. Here you can see this component in diagram. So when the coolant will continue to circulate like this until it reaches the design temperature, at which point the thermostat will open a valve and allow the coolant back to the radiator. In order to prevent the coolant from boiling, the cooling system is designed to pressurize it. Under pressure, the boiling point of the coolant is raised considerably. However, too much pressure will cause hoses and other part to burst. So, its system is needed to relieve pressure if it exceeds a certain point. The job of maintaining the pressure in the cooling system belongs to the radiator cap. It is designed to relieve pressure if it reaches the specified upper limit. A liquid-cooled engine produces more power or torque than an air-cooled, whereas air-cooled engines are fuel-efficient, affordable, and require lesser engine space than that of liquid-cooled engines. Now let's talk about new radiator design. On the basis of rate of heat dissipation and other heat transfer characteristics, there can be two major modifications in the radiator. First one is use of carbon foam fin, and second one is use of nanofluids. Now talk about carbon foam fins. Here in this diagram, you can see this is an aluminum foam fin and this is an carbon foam fin. Experiments suggest that engine cooling efficiency can be increased by the use of carbon foam fin instead of aluminum foam fin because carbon foam increases the surface area exposed to the air. Also, the porosity of carbon foam fin is higher compared to aluminum foam fin. That's why air can easily flow through the carbon. Porous carbon foam has an open, interconnected internal structure. Other benefits of using carbon foam fins are lightweight, high temperature material with resistance to fire and chemicals. The compressive strength of carbon foam fin is 25.8 megapascal. Now let's talk about use of nanofluid, the second major and important modification in engine cooling system. Nanofluid is a two-phase mixture composed of very fine particles in suspension in a continuous and saturated liquid. Water, ethylene glycol, engine oil may constitute a very increasing alternative for advanced cooling system. It may be possible that important heat transfer enhancement may be achieved by using nanofluids compared to the use of conventional fluids. Nanofluids are suitable coolant due to its high thermal diffusivity and can be applied to any system that needs a quick response to thermal changes such as vehicle engine. The presence of nanoparticles in nanofluid contributes better flow of mixing and higher thermal conductivity compared to pure fluids. Now let's talk about the analysis we have done in this topic. In case of aluminum foam fins, it requires higher surface area to meet cooling needs, whereas higher heat transfer rate can be achieved by the use of carbon foam fins. By the use of nanofluids in radiator, we can achieve higher rate of heat transfer even in warm summer days, and our engine can work efficiently. An advanced automotive engine cooling system can positively impact the performance of fuel economy and reliability of internal combustion engine. The application of carbon foam as the radiator material in the design shows an increased rate of heat transfer is much greater than conventional rate of heat transfer. Carbon foam radiator can be made 33% smaller in size than the aluminum foam fin radiator. That means we have extra space in engine compartments. Nanofluids also shows an increased rate of heat transfer. This rate of heat transfer is greater than required value and hence radiator can work efficiently even at higher speed requirement in hot climate conditions. Okay, I have completed my topic. Anybody having any query or doubt can ask. Now I will be happy to answer.
Yes. What are 5 main parts of engine cooling system?
The major components of the cooling system are the water pump, freeze plugs, the thermostat, the radiator, cooling fans, the heater core, the pressure cap, the overflow tank, and the hoses. Any more question?
Yes. What is air cooling system?
Yes. Air cooling is a method of dissipating heat. It works by expanding the surface area of increasing the flow of air over the object to be cooled, or both. Air cooling is a process of lowering the air temperature by dissipating heat. It provides increased airflow and reduced temperature with the use of cooling fins, fans, or field coolers. Any question?
No.
Thank you.
So basically